Hi, this is Teacher Ai. Welcome to my class.
Our lesson for today is all about prepositions, simple and compound prepositions, type of operations on prepositions. Our objectives are illustrates and symbolizes prepositions, distinguishes between simple and compound prepositions, and performs the different types of operations on prepositions.
Let's have our first activity entitled Which is Which. Here, you're going to read the given sentence and identify what type of sentence are those. Is it a declarative, exclamatory sentence, imperative sentence, or interrogative sentence?
Now, let me give you 1 minute for you to read and analyze the given sentence and determine if it's declarative, exclamatory, imperative, and interrogative sentence. Now, let us find the answer. The first one is a sentence that gives your eye is the lamp of your body. This is clearly an example of a declarative sentence. The second one, when did you last hug your parents? This is in the form of a question. Therefore, it's in the form of interrogative sentence. For the third one, admit your fault. This implies a command. Therefore, it's an imperative sentence. The fourth one is a greeting, which is happy birthday, and it claims to be an exclamatory sentence. The last one, life is a blessing. This is a thought and declares to be a declarative sentence.
Now, let's have another activity entitled Is it a fact or a bluff? Here, you can use a Google or a book to research if the given statements give a complete fact or not, which is a bluff. Good luck and happy learning!
Now, let us now start with the first given trivia. You are taller in the morning than in the evening. Is it a fact or a bluff? Correct! It's a fact. Researchers observed that people in the morning are much taller than in the evening. Next, let's have the second one. By the age of 18, your brain stops growing. Is it a fact or a bluff? Correct! It's a fact. Now, let's have the next one. Soreness stays at the tip of the tongue. Is it a fact or a bluff? Correct! It's a bluff. How about this one? There are more Chinese than Americans. Do you agree to that? According to a given research, there are 1.44 billion Chinese and only 331 million Americans. So this thought is a fact. Now the next, melatonin gives color to our skin. Is it a fact or a bluff? It's a bluff because melatonin doesn't give color to our skin. It only darkens the skin of animals and plants. Now, let's have the last one. COVID-19 is a virus. Is it a fact or a bluff? It's a bluff because COVID is a disease caused by SARS-CoV-2 virus.
I I know you are familiar with the movie Squid Game. Here, we're going to use some shapes that were used in the movie to be able to learn how are we going to identify the different kinds of statements involving propositions.
Now, let's have an activity regarding the title, Identify Me. The direction states that identify which of these statements are propositions or not by means of putting a symbol in each statement, triangle for propositions and square for not. I will give you 1 minute to read each statement and group them according to the direction. Now, let us reveal the answer. Here, as you observe, letter A, B, P, P1, P2, P3, and P4 are highlighted in yellow color. This means that these are the words that are chosen to be under propositions, while letter B, C, and D were mentioned as not a proposition. Now, let us describe these words which is not a proposition. Let us observe. Letter B states wear your mask, which is in the form of an imperative sentence. It gives a command. Letter C, happy birthday, is a form of exclamatory sentence. Therefore, it's not a proposition. And letter Q, never mind, I am just joking. This is just a phrase and doesn't give an idea as a form of declarative sentence. Now, let's have the different propositions that were grouped in the shape of a triangle. For letter A, proposition A, COVID-19 is a virus. For D, there is no stronger than the heart of a volunteer. P, 3 factorial is equal to 6/2. Although they are not correct, but then it gives a mathematical sentence. Next are the group of P's of 1, P's of 2, P's of 3, and P's of 4. Let us read each of the given proposition. For P's of 1, if an individual is great, then there is a feature behind. P's of 2, either a person saves before spending or one spends before saving. P3, it is not shamed to greet the utility worker the same way as with the school principal. And for P4, if a person is disabled, then he or she is entitled to obtain a PWD ID. And if a person is entitled to obtain a PWD ID, then he or she is disabled.
Now, based on the given activity, which we have already identified, which is a proposition or not, let's have now a new topic, which is all about simple and compound propositions.
Let us define simple and compound propositions. A simple proposition is a proposition that cannot be broken down into more than one proposition. Otherwise, it is a compound proposition. The latter is a proposition that is formed by joining simple propositions using logical connectors. Based on the activity that we have done a while ago, let us describe the two given propositions which is described to be a simple proposition. Proposition A, COVID-19 is a virus. There is no illogical connector within the sentence. Proposition B, there is no stronger than the heart of the volunteer. Gives a clear idea that the given sentence cannot be broken into two. Now, let's move on to compound propositions. Given the first proposition, if an individual is great, then there is a teacher behind. They use the word if and then. If and then are known to be logical connectors. Therefore, the given proposition is a compound proposition. Let's have the next one. Either a person saves before spending or one spends before saving. Observe that there is a logical connector, the word or. This means that this is a compound proposition. The third proposition, P3, it is not shamed to greet the utility worker the same way as the school principal. The word not gives a connection between the greetings to the utility worker and the principal. Therefore, this is a form of compound proposition. The last proposition is, if a person is disabled, then he or she is entitled to obtain a PWD ID. If a person is entitled to obtain a PWD ID, then he or she is disabled. They use the word if then, which is a logical connectors. Therefore, this given proposition is a compound proposition.
Now, after determining the characteristic of a simple and compound proposition, let's now have an activity entitled Simple or Compound. Here, your task is to identify if the given proposition falls under simple, compound, or none of these.
Let's take the first one. If bad company ruins good morals, then one should be mindful in choosing friends. Let us observe the given sentence. Is there a logical connector within the sentence? Let's identify the word if and then. Therefore, this proposition is a compound proposition. Let's take the next one. Face mask protect people. Can you see a logical connector within the sentence? If not, therefore, it's a simple proposition. Moving on, let's have the next one. Ponder on the sacrifices of your parents. Is it simple or compound? First, let us observe if there is a logical connector on the given sentence. Is it an idea form of a declarative sentence? If then, therefore, we can say that this is a simple proposition. Next idea of the given proposition. If you study hard, then you will have good grades. Observing the given sentence, there is a logical connectors if and then, which implies that the given proposition is a compound proposition. How about this one? Have you thought of the sick when you are spending too much? Let us observe the given sentence. Is it a declarative sentence or an interrogative sentence? Based on the given thought, it's in the form of a question. Therefore, any interrogative sentence cannot be considered to be a proposition. Therefore, that is none of these given choices. It's either simple or compound propositions. For this, you may be unprotected or a danger if you are not vaccinated. You may be unprotected or a danger if you are not vaccinated. Let us observe the given proposition if it's simple or compound. Is there a logical connector within the sentence? As I observe, there is the word or, which implies that the given proposition uses a logical connectors. Therefore, we can say the given proposition is in the form of a compound proposition. Taking the next one, there is wisdom in spending for needs, and it makes sense to think at least twice before giving in for wants. Again, there is wisdom in spending for needs, and it makes sense to think at least twice before giving in for wants. Let us observe the given sentence. Is there any logical connector within the sentence? Let us read again. There is wisdom in spending for needs, and the word "and" is a logical connector, which gives this proposition a compound proposition. Let's have this one. Two lines are parallel if and only if they are coplanar and do not intersect. Observing the given, is there any logical connector on the given sentence? The word if and only if proves to be that the given proposition is in the form of a compound proposition. Let's take this one. Study hard and rest well. There is a logical connector within the given sentence, but then this is in the form of an imperative sentence, which means that it cannot be a proposition. Therefore, this is none of the given choices. It's not either simple or compound. Be vaccinated. This is in the form of an imperative sentence because it gives a command. Therefore, it's neither simple or compound.
Now, let's move on to our next topic, different logical operations on propositions. Before we start with our topic, let us first determine how to make a truth table. First, we need the two given truth value, true and false, followed with the propositions. For example, we have two propositions with a given two truth value. How can we make a truth table? Now, let us try how to make a truth table. Given two propositions with two given truth values, we may arrive at given two truth value is raised to the proposition which is given. Therefore, 2 raised to is equal to 4. We may now create a table with having 4 rows. We have 1, 2, 3, and 4. Thus, the proposition P includes the truth value true, true, false, false, while the proposition Q have a truth value true, false, true, false. Now, what if the given propositions are 3 with 2 given truth value? Then writing again, given the 2 truth value and 3 as the number of propositions, we may have 8 rows. In illustration, we may have this given table. The 3 propositions are P, Q, and R, having 8 rows. So 1, 2, 3, 4, 5, 6,
7, and 8. Dividing the given truth value into 2, we have 4 true and 4 false. While under the proposition Q, we have true, true, false, false, true, true, false, false. And under the proposition R, we have true, false, true, false, true, false, true, false, which is presented in our truth table. Now, after determining how to make the truth table, let us start now with the first logical operations involving proposition. The first one is negation. The negation of a proposition P is denoted by a tilde P, which is read as not P, and it is defined through its truth table. Given the proposition P and the negation P. With the proposition P, true, false, the negation of true is false, and the negation of false is true. Now, let us apply this in a statement. Let's have the proposition, I am happy. What would you think would be the negation of P? Correct. I am not happy. So, if we're going to analyze, it is completely the opposite of the given proposition as a means of negation. Let's have another one. Josephine is coming. What will be the negation of the given proposition? Negation Q will be Josephine is not coming. And let's have the next one. Today is not a good day. We're going to observe the proposition is in the form of negative. Not all propositions should be in the form of positive to get its opposite. Other way around, if it's in the negative, we can make it into a positive, which is the negation of R is today is a good day. Let's have the next one, the conjunction. States that conjunction of the proposition, which is denoted by this symbol, and it's read as P and Q, and is defined through its truth table. Propositions P and Q are called conjuncts. The conjunction P and Q is true only when both conjuncts P and Q are true. Now, let's take a given table for us to be able to observe how conjunction implies. Using this given table, we have two propositions, proposition P and proposition Q. Writing its truth value, we have true, true, false, false. And under the proposition Q, we have true, false, true, false. Now, illustrating the logical proposition or operation of the proposition P and Q, as we observe, the first one, true, true, which clearly manifests the description of conjunction, which is when the two given conjuncts are true, then that is true, and the rest are false. Now, let us apply conjunction in the following statement. Using the two given propositions, there is an advantage of physical exercise under proposition P and proposition Q. It makes our body healthier. Given the symbol, let us translate this to statement. There is an advantage of physical exercise and it makes our body healthier. So which shows P and Q. We use the connector and to show that this is a conjunction. Second one, this statement, we're going to translate it to symbol. There's an advantage of physical exercise, which is the proposition P. And it doesn't make our body healthier, which is the opposite of the proposition Q. In symbol, we arrive at P and negation of Q. Now let's have the next one, the disjunction. Disjunction of proposition P and Q is denoted by this symbol, which is read as P or Q, and defined through its truth table. Propositions P and Q are each called disjuncts. The disjunction P or Q is false only when both disjuncts P and Q are false. So remember, if the given two propositions are false, then the truth value will be false. Now, let us use a given proposition of the disjunction into a form of a table. It's said to be that the disjunction P or Q is false when both disjuncts P and Q are false. Let us observe the truth table. Given the proposition P and Q, which have the truth value true, true, false, false, true, false, true, false. Identifying that the given disjunction only involves this part, which is they are both false. Therefore, it implies that the truth value, if the given propositions are both false, therefore it is false. Now let us apply the given propositions into statements under disjunction. Let's have this different proposition. We have proposition J, laughter is the best medicine. Proposition K, grief causes illness. Proposition L, prayer relieves pain. Proposition M, God takes charge of worries. Let us translate the first one. J or K. J, which is laughter is the best medicine. K, grief causes illness. Lying, the disjunct, which is the word or. We have laughter is the best medicine or grief causes illness. Next one is this given statement. We're going to translate it to symbol. Grief causes illness is the proposition K using or as a symbol for disjunct, and prayer relieves pain as proposition L. We have K or L. The last one is the negation of L or M. Since L, the proposition L is prayer relieves pain, and the proposition M, God takes charge of worries, we have prayer will not relieve pain or God takes charge of worries, which express complete thought under disjunction. Moving on, we have the next logical operations on propositions, which is conditional. This is another kind of logical propositions, which includes a conditional statement. The conditional of propositions P and Q is denoted by P implies Q, or if P, then Q, which is defined through its truth table. It's always noted that a proposition P is called the hypothesis, while the proposition Q is called to be the conclusion. Let us use a truth table for us to be able to understand a proposition under conditional. Observing the given table, we have the truth value under the proposition P, which is true, true, false, false. And under the proposition Q, we have true, false, true, false. Now, using the given logical proposition P implies Q, you can observe if the given two propositions are true, the answer, the truth value is true. If the given proposition is true and false, the given truth value will be false. And if the given propositions are false and true, it will be true. And if they are both false, then that is true. So if we're going to observe, there is a hint which gives us a clear idea that if the given statement is false, when the given hypothesis is true, then that is false. Let's take this example for us to be able to understand deeply the definition of a conditional proposition. Let's have the two given propositions. Proposition P, you pass the exam. Proposition Q, I will treat you a lunch. These two given propositions can be applied in the condition that has been stated on our given table. First, let us use the first statement. If you pass the exam, then I'll treat you a lunch. If you pass the exam, then I'll treat you a lunch. This is true and this is true. If you pass, that is true. Then if you treat a lunch, that is true. Therefore, the truth value will be true. Next one. If you didn't pass the exam, then I will treat you a lunch. Imagine, even if you didn't pass the exam, then you will still be treated with a lunch. In this case, we have false and true. Even the hypothesis is false, but then the conclusion is true, then that is true. Next, if you didn't pass the exam, then I will not treat you lunch. It's a fair condition, because if you didn't pass the exam, you will not also be treated with a lunch. And with this kind of condition, we can give that is true. But if you pass the exam but you were not treated with a lunch with the given condition, that is clearly false. So with this kind of example, it clearly manifests or explains how conditional proposition lies. Now let's have the biconditional. Biconditional is the last logical proposition we should consider in this kind of discussion. This is denoted by P if and only if Q, given the propositions or components P and Q, and it is read as P if and only if Q, and defined for its table. Let's have these key points or key ideas. Under biconditional, whenever the two statements have the same truth value, the biconditional is true. Otherwise, it is false. Always remember, if the two statements have the same truth value, means they are both true or both false, then the given truth value is true. Otherwise, it is false. Let us apply it in a given table. Let us observe that proposition P is true, true, false, false. Under proposition Q, we have true, false, true, false. Observing the first given proposition, they are both true, that is true. Then at the bottom, we have both false, and that is true, and the rest are false. Now let us apply this in a given statement. Let's have G, H, I to be a proposition. The proposition G is read as only physical handicapped individuals can be called persons with disabilities, while proposition H, psychosocially disabled persons like those with chronic illnesses can also avail PWDID. The last proposition I, there are numerous benefits which come along with owning a PWDID. Now, let's have this given propositions and let us translate it into symbol. Only physical handicapped individuals can be called persons with disabilities, if and only if psychosocially disabled persons like those with chronic illnesses can also avail PWDID. We have the first one, which is under proposition G, and the second proposition is under proposition H, which implies the word if and only if, which is read to be G, if and only if H, and symbol. Let's have the next one, using this symbol and translate this into a statement. We have the negation of H, if and only if I. Since H is psychosocially disabled person like those with chronic illnesses can also avail of PWDID, if we're going to negate it, we're just going to write not psychosocially disabled persons like those with chronic illnesses can also avail PWDID. If and only if, using symbol and using the letter I or the proposition I, there are numerous benefits which come along with owning a PWDID. So this is how we are going to translate the given symbol into a statement. Now let's have this another example. Using this symbol, let us translate this into statement. G, as mentioned in our proposition, and H, as mentioned here, as psychosocially disabled person, and the conjunction and the negation H. Since H is psychosocially disabled person, we're going to negate it. We're going to transform it into not all psychosocially disabled persons like those with chronic illnesses can also avail PWDID. So in symbol, we have only physically handicapped individuals, which is our proposition G, can be called persons with disability if and only if, following the given symbol, psychosocially disabled person, which is our proposition H, and using the connector or the given conjunction and negating the given proposition H, we have not psychosocially disabled person, And lastly, applying again biconditional, which is if and only if, this one, there are numerous benefits which come along with owning a TWID using the proposition I. So that is how to translate the given symbol into statement. Activity 5, truth or dare. These are the given logical operators that we're going to make in a given truth table. Stating that in the given table, we have the two given propositions P and Q. We have true, true, false, false, true, false, true, false. To be able for us to illustrate the negation P, we will have the opposite of this given proposition. We have true, that will become false, true will become false, false will become true, false will become true. While negating the Q, this will be the complete opposite of this given proposition. This will become false, true, false, and true. Now, applying the proposition, the conjunction P and Q, that the two given propositions, if they are both true, then that is true and the rest are false, since we are just using P and Q, we will have true and the rest are false. How about the negation of P or Q? Here, the two given propositions are both false, then that is false and the rest are true. It's the complete opposite of the conjunction. Now, since the negation P will be used as our first proposition to connect with our given proposition Q, we're going to read it this way. Proposition negation of P or Q. We will have true, false, true, false. Since this is only having the two given proposition having two given truth value of false. Let's have the biconditional. Under biconditional, we can state that the given statement if the proposition are the hypothesis implies to the conclusion which is true, but not to contradict the given hypothesis with a false value. Like this one. We have true, true, while true, false will have false and the rest are true. Under biconditional, if the two given propositions are false or they are the same, therefore they are both true. So here, if we're going to observe, the two given propositions which is both the same are the first and the last one. So we will have true and the two given one is false and the last one is true. So that is our answer for activity number 5. Another activity, which is translate me. Using this given symbol, we're going to translate this into verbal sentences. Using this given proposition. Proposition A, you are what you eat. Proposition B, your food can describe your health. And proposition C, by nature, human is designed to eat. And lastly, proposition D, a person should eat healthy food. Let us use the first one. Negation of C and B, if and only if A. So here, we're just going to negate C, then connect it with the word and then use the proposition B, and then implies if and only if connecting the proposition A. The answer will be, by nature, human is designed not to eat, because that's division, and if that is conjunction, your food can describe your health if only if that is a biconditional proposition. So if and only if you are what you eat. So that is proposition A. Now let's have the next one. A or B implies B. So we're just going to use you are what you eat or your food can describe your health if a person should eat healthy food. So in symbol we have if you are what you eat or your food can describe your health, then a person should eat healthy food. So we use the different symbol or the negation, the logical operation or, and if, and the word then, to show the conditional proposition. Now let's take the next one. The negation of B, if and only if, the negation A, and the negation B. Here we're just going to negate the given proposition D, A, and B and connect it with if and only if and the word and. In translation, into verbal sentence, we have person should not eat. So we're going to observe not eat, the negation of letter B. If and only if this implies the given biconditional, you are not what you eat, and the word and, which shows a conjunction, and your food don't describe your health. So, in a complete thought, we have a person should not eat food if and only if you are not what you eat, and your food don't describe your health. This one, let us express the following propositions in symbols. Let's have this 1, 2, and 3 given statement using the given proposition. So there's wisdom in spending on needs. Position E. It makes sense to think at least twice before giving for once. F. A good planner saves first before spending, and last, as a shopaholic should learn self-control. Let us translate it into symbol. A good planner, so that this is a proposition F. If then implies a conditional, and the word and is conjunction, and conjunction which connects the proposition makes sense to think at least twice before giving in what you want. So the word that is being mentioned is the proposition F using the proposition D and proposition E. So in symbol we have F implies D and E. Okay, let's have the next one. A shopaholic should not learn self-control only if a good planner does not save first before spending, and it does not make sense to think at least twice before giving in for once. So you can observe the word not, does not are all negation, and they use the word if and only if, which is biconditional, the word and, which is conjunction. Now to illustrate this, the given propositions to mention are proposition G, proposition F, and proposition E. Symbol, we have the negation of G, if and only if, the negation F, and the negation of E. Now, let's take another given statement and translate it into a symbol. There is wisdom in spending on needs, or a shopaholic should not learn self-control. Clearly stated that we use a disjunction. And we negate the given proposition G and using the proposition D. Symbol, we have D or negation G. Now let's have this enhancement activity entitled by or gone. You may pause this video for you to be able to answer the given task, or you may follow or listen to the instruction for the discussion of the answer. Using this truth table, let us determine the answer for number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Using the first one, what a negation? So the negation is the complete opposite of the given proposition. So we have negation of T, this is true, then we have false. This is false, then we have true. This is false, then we have true. Next one, under negation of Q. So there is no question regarding here. Now let's move on to P and R. So this is a complete proposition involving conjunction. So in conjunction, if the given two propositions are true, then that is true. So we're just going to look for P and R and number 4. So they are both true. So we can say that that is true. Using number 5, we have false and true. They are both different, so we have false. Let us now have the disjunction Q or R. In Q and R, if the given propositions are both false, that is false and the rest are true. So we are going to look for Q and R. So since here they are both false, then we can say that that is false. Same with the given here, they are both false, and we have false. Going to 8, which is under the proposition of a conditional, which is P implies the negation of Q. So here we are going to check the propositions under P and the propositions under the negation Q. So we're referring to two given truth value, which is both true. So here the answer is true. For 9, which is biconditional, so here if they are both the same proposition, then that is both true or other way around, false. So here we have the given proposition Q and R, which is true and true. So we have true. Moving on to 10, which is going back again to conditional, we have P and negation of is false and true. So we can say that the given condition or truth value will be true. That is our answer for our enhancement activity. Now, let's take a summary. Propositions, statements in the form of declarative sentence. It can be true or false as long as in the form of either simple and compound proposition. Simple propositions are sentences which cannot be broken down into two given sentences and doesn't have a logical connectors, which is described under compound proposition. We also have the different operations on proposition, which is the negation, conjunction, disjunction, conditional, and biconditional. Now, how can we apply this given lesson? So this application is used commonly under empowerment technologies. So you can find it in our Excel, the logical operations, which is used as and, then, not, or, so on. So these are the application of logic under propositions. As an additional performance task, you may use this activity for COVID awareness using this given proposition, which is going to make a best logical statement using this given proposition against COVID, about COVID-19. Proposition P, COVID is a virus. Proposition Q, it kills many people. Proposition R, vaccine will help prevent the spread of virus. And proposition S, protect our children. And to end up my lesson, I want to end this with this given quote: logic is the anatomy of thought. With that, thank you and happy learning to each and everyone. Bye!